Hey everybody, welcome back. Today we're going to be working through question 3 of the Winter 2022 midterm exam. And this question is all about compilation and linking. And so what it's asking us to do is to work through the symbol and relocation tables of this example program that we have here. And then we're going to have a follow-up question with regards to our findings. So because I don't want to scroll back and forth between the tables constantly, I'm going to kind of annotate the program. But the exam's expectation was that you could hold these pages side to side and then add to your symbol and relocation tables accordingly. So let's go ahead and get started. So let's start with the symbol tables for each of these C files, and we're just going to kind of work our way down line by line, and then I'll annotate anywhere where we need to, or we see a symbol with its type. Okay, so first line of burrito.c, we see that we're externing a function, and so what that says is essentially, I don't know where this function is. Somewhere in the linking process, I expect to have a file that will have this function declared. However, what does that say about like its location? Well, essentially it's unknown, right? So in my symbol table, I would have the symbol and it would be annotated with unknown. So line 3, remember, a define is just a compiler directive. It's like before it compiles, it's going to replace anywhere it sees max toppings with just the value 100. And so this isn't a global variable or anything. In fact, it's not a variable at all. It's just kind of a representation of that value. Max toppings is the equivalent of seeing 100 anywhere. So then on line 5, again, I'm externing an integer. This again means that this variable is declared in some other file and the linker should resolve it. But for now, I don't know where it is. And so my location or the type of this is going to be U for unknown. So then I am declaring a variable, and because this exists variables kind of like in global scope, this is something that needs to be in the symbol table because another file might want to be able to access that variable, right? And so where is this going to be located? Well, it's just a variable, and so essentially it's going to belong in the data in like a global data segment. And so this is going to go in the symbol table as well, and it's going to go under the data type. Awesome. So then we declare a function called makeBurrito, right? So what we need to consider is that another file might want to call the function that's declared in burrito.c called makeBurrito, right? And so I need to make that accessible globally. And so this is also going to belong in the symbol table. And because it's a function, it's going to belong in the text segment of the program. And so this is going to go in my symbol table under text. So then I can kind of look through the body of this function. And I see that I'm not declaring any static variables, right? Any variables that are declared, like I, all exist within the scope of the function, right? So they're not at global scope, so I don't have to worry about that. And I also see that I'm, not performing any externs or anything in there. And so that's all we're going to have for the burrito.c file. Moving on to the helper.c file. We have a couple of includes. Again, those are like linker directives. And then we see that we are externing a char burrito or pointer to a char, or really, as we know, it's going to be an array. or I guess an array of pointers, but we're externing that. And so essentially we don't know where that variable is located currently, and it's going to be linked from another file. And so currently it's going to be unknown in our symbol table. Again, so then on line 6, we're declaring a variable at global scope. And so this is going to belong in the data segment of our file, but it belongs to the symbol tables because other files might access it. Then on line 10, we're declaring a function. Again, another file might want to access this, and so we need to put this in the symbol table, and it's a function, so it's going to be long in text. Awesome. So then we are going to be looking inside the body of our function, and it looks like we are making a call to a function called by, right? So let's think about that. Let's look at our local file. We see that we can't resolve by locally, right? By isn't a local function, and so it must belong, in one of these two libraries that we're including. Regardless, I don't know where this function is when I'm compiling just helper.c, and so it needs to be something that's linked, and so it belongs in the symbol table. But the location is currently unknown. Obviously, the linker's going to resolve that, but for now, it's going to be unknown. Super similar thing for the next line where we're calling string copy. So, we don't declare string copy as a function locally, so it's going to have to be resolved when it links, when the linker links it with string.h. And so this is also going to be unknown. Awesome. So that's the entirety of the symbol tables. Moving on to the relocation tables. So recall the relocation table is essentially, it essentially handles any changes to instructions that might happen. So we're usually going to see this with regards to branching instructions when we have like a global, a non-local global function, right? So an example that comes to mind just looking at this would be like line 12 by, right? So I'm going to need, currently the value is going to be like unknown because I haven't resolved where that function is. So the relocation table is kind of just like a reminder saying, hey, I need to resolve this when I'm linking. So and then the other types of instructions that we need to account for are loads and stores, right? Because our data segment could be potentially separated from the text segment of our files. And so as a result, I need to fix the offsets for each of these. So we can kind of work our way down. Again, I'm going to switch for colors really quick so you can see what is going to belong. Which one? Okay. So relocation table entries are really going to belong anywhere in like inside functions or anywhere different things are being executed. So we can really start on like line 14 in the case of burrito.c. So num toppings is a variable that's declared in local scope, so we don't really have to worry about it. Max toppings is also something that's located in local scope, or I guess it's just a number, right? It's the equivalent of just saying 100. And so we don't really need to worry about that. Then starting on line 20, I is also local. And num toppings is local, so nothing on line 20. On line 21, right, however, we are calling helper, right? So helper is this function that we externed earlier, right? And so that's currently, like if I was just compiling burrito.c, we wouldn't know what offset to branch to, right? And so as a result, on this line, we're going to see that we're going to perform a branch instruction, right, where I'm going to need to relocate or fix the offset for this branch instruction once I link it with, in this case, helper.c. Then so toppings is also a local variable and width is also a local variable. So that's all I have for line 21. On line 22, however, I am accessing this variable called location, right? So location is, again, one of those variables that I externed earlier, right? So it's going to belong in a different file. So currently I'm going to have perhaps incorrect load and store offsets, right? So I'm going to need to resolve and then fix the location for both for this line. So recall that, plus equals 1 is essentially saying location is equal to location plus 1. And so I'm doing two things to location here, right? When I compile this into assembly, I'm going to be performing a load instruction, and then I'm going to be performing a store instruction. So I'm actually going to have two entries in my relocation table for the singular line for both a store as well as a load. Awesome. So that's all we have for those three entries are going to be all we have for burrito.c. So moving on to helper.c. Again, we can pick up where we're actually running instructions, right? So that's going to be on line 12. And so, okay, so on line 12, the first thing I notice is that we're going to be calling a function, and this function is currently unknown in our symbol table, and therefore we need to resolve it. And so when we do resolve it by linking, we need to fix the offset that we're branching to. And so as a result, what we're going to see is that this belongs in the relocation table as a branch instruction. Awesome. So then what else do we have on line 12? A reading topping, which is a local variable. We're also reading width, which is also a local variable. So that's all we're going to have for line 12. Moving on to line 13, I see that we have a string, another function call. And very similarly, right, that's currently unknown. And so we're going to have a branch instruction, BL, for line 13 to resolve string copy. So then what else is happening here? We're also accessing this array called burrito, right? And so burrito, if we look at its, sorry about that. Let's see if I get disconnected real quick. Burrito is this array that is currently unknown, right? If I was compiling and looking locally, it's in my symbol table as an unknown variable, and so as a result, this is something whose offset needs to be fixed, right? And so, well, here I'm trying to load the value inside it, and so I'm going to have associated with reading burrito a load instruction. Awesome. So then I have the variable location. So location is a global variable, but because it is a global variable, and so while it does exist within helper.c, what we need to consider again is that our text segment and our data segment might get moved around relative to each other, and so there's the chance of locations offset changing, right? And so if I want to be able to read location, I still need to perform a load instruction because it's a global variable. Awesome. Then we have topping, which just exists within the scope of the function, so we don't have to worry about it. So in total, we're going to have 4 entries in our relocation table: a branch for buy, a branch for string copy, and then loads for each of burrito and location. Okay, so that was part A. Part B says you have burrito.o and helper.o from a previous compilation. You change the initialization of int location equals 0 on line 5 of helper.c. So we're changing helper.c to a different integer value and create an executable containing this change. Which files, if any, must be recompiled? All right, let's think about this. So we're changing helper.c. So what does that mean? Well, if I want to change helper.c, that means at minimum, right, I need to recompile helper.c, right? Because if I don't recompile, that change isn't going to be reflected in the executable at all, right? So if we say no, gosh, we say recompile, we need to have recompile at least helper.c. Right. So the question is, do I need to recompile burrito.c? I do not need to compile burrito.c for the reason that compilation only applies, right? I only need to recompile if there's changes to my the file that I'm applying the change to, right? So sorry, to clarify, because I'm changing nothing in burrito.c, right? And the compilation process doesn't affect, it's not affected by changes to other files. Compilation only considers what it knows locally. So as a result, we're not going to need to compile burrito.c, right? So we're only going to recompile helper.c. So now the second part of this question was asking us what must be relinked, right? Well, essentially, we have to relink these files, burrito.c and helper. Or I guess the object files associated with them, burrito.o and helper.o. And the reason that we need to do this is because because by changing helper.c, right? So it's obvious that we need to, or it should be a lot more clear that we need to relink helper.o because we changed the object file by recompiling it. But the reason we also need to relink burrito.o is because by changing helper.o, we need to consider the possibility that by changing that file, data got moved around, right? Some offsets got changed. In this case, all we did was change the value in it, right? But all that we can differentiate is that the file changed. That's the only view that I have. And so if the file changes, there's the chance for offset to change. And so we might need to fix all of our offsets again in a burrito.o. So with regards to relinking, right, we need to link both of their object files. We're gonna have helper.o as well as burrito.o. Awesome. All right, that's all we have for question 3. Hopefully I'll see you next time with question 4.